Hello and welcome back again here at the Pitchnext event on our industry stage at the Formnext 2023. We are at our third block regarding the topic of hardware. And I tell you what, hardware, in the meantime, it's no longer a topic of printers we are talking about. It's much more, whether it's automation, quality control or post-processing, there is exciting hardware to explore in each of these fields. Our first startup in the field of hardware deals with the testing of finished products and provides an appropriate tool for this purpose. So Peter Zock from Imprintec explains us to how this works and what significance this has for its field of application. Peter, stage is yours. There he is.
Yes, hello together. So my name is Peter from Imprintec, and today I'm curious to present you our latest development. It's a hybrid AI-powered testing technology, and with this we are able to test materials in a way that was previously not possible. So let's take a look together. What do all these things have in common? Just a moment. They should be designed robustly against external forces. This means all structures rely on understanding the mechanical properties of their components. And for this, the tensile testing and hardness testing are standard methods. Tensile testing is the gold standard for characterizing mechanical properties. For this, you always have to prepare a tensile test sample, and this is time-consuming and costly. On the other hand, we're talking about hardness testing. This method provides a possibility to characterize the properties and get hardness values. A hardness value on its own is limited to the whole picture of mechanical properties. For example, yield strength is missing, and we asked ourselves if we can do it better in a way. And what we developed is, we call it i3D technology. And we're using the speed and efficiency of hardness testing and combining it with a new 3D measurement device where we detect 3D data out of indents and are able to get more information out of it, like yield strength and tensile strength. And here, for example, you see also a prototype which was ready to build in inline processes to get very fast data. Here you see some achievements from us. In the last year, we get a total revenue of approximately 1 million euros and get bigger grants in R&D. Also, we started our distribution network for products in Europe with partners. Yeah, thank you very much for your attention. When you want to get a first-hand experience of this technology, please visit us and have a great week at Formnext.
Thank you so much, Peter. Awesome presentation. So just a quick question, because I'm already on a time pressure. So you have the device with you and everybody can see it?
Yes, exactly.
What is the type of customer you're looking for?
We're looking for customers who are building metal parts, and especially in products where higher strength are necessary to get safety done. For example, some parts for seating, doors. Also, we're working for example, together with Rolls-Royce, when they want to test the blades of the turbines, everywhere where it's very difficult to take out tensile test samples and you want to get very fast on low level of costs to the same results.
Awesome. Thank you so much. So I wish you all the best for Formnext. Collect a lot of clients. A very good product. Good luck for the future. Okay.
Yes, thank you very much.
Peter, thank you so much. Enjoy the fair. So I don't know about you, but I must admit that since I discovered additive manufacturing, I was dreaming of having my own 3D printer. There were two issues. First of all, I don't have any technical knowledge, so I couldn't use it at all. And on the second hand, I don't have the money to afford it. But if I would have a printer, I would love to have one that could use multiple material in order to fulfill the dreams of my personal products that I want to produce. The next startup actually offers a portfolio that mainly addresses B2C customers, and that's super exciting. And I'm super curious to see if my dream solution is among their portfolio. I would like to welcome Ömer Fatih Aman, Sales Manager at Coprint. Ömer, stage is yours.
Hi. Hello everyone. This is Ömer from Coprint 3D Printing Technologies, coming from Turkey. And here we are going to talk about the Coprint, what we did in the past and what's waiting us in the future. Coprint was established approximately like 3 years ago. The main problem here was 95% of the 3D printers, what I'm talking here is the consumer grade 3D printers, the home type ones, had a single print tip. And secondly, they were not able to change out materials and filaments in a single print duration, and there were limited options available in the market. So before going for the first product, let's take a look at our roadmap. The first MVP was published in third quarter of 2019. And in the fourth quarter of 2021, we made our first Kickstarter campaign, starting with a pre-sale journey of our first product. And then in the last quarter of 2022, we raised $1 million funding. And here we are live on our second Kickstarter campaign, currently on the Kickstarter page. This was our first solution for the FDM grade 3D printers. It was only compatible with Bowden extruders. It was allowing users to control up 7 different materials or 7 different filaments in a single print. But there were some issues. We were not able to control direct drive 3D printers. So we came up with our current solution. Introducing Coprint Chroma Set, consistent of 5 different products. ChromaPad is the brain, controlled by an open source Clipper software, but we completely revised it to have multi-material prints. KeyCM is specially designed for existing Clipper 3D printers. So let's say that you have a Clipper 3D printer, you don't have to buy the pad, you just go with the KeyCM. ECM is to control different filaments, add up different extruders up to 4, and with adding up 4 different ECM modules, you will have 20 colors in a single print. Extruder is for a stronger grip, and Chroma had as the perfect solution for having smoother prints. So here we have the main specs of our set. Basically, we are controlling 8 printers in a single panel, so that you have a printer farm, you will be able to control it in a single panel. And because of the software inside of the pad, you will have 60% less printing time. And additionally, it gives you a universal compatible printing CAD. So let's say that you have different rail systems. You are using Creality, Prusa, or any other machine that is on the market. We have different rail systems that you can plug in. And in the head, we use a special hot end that goes up to 350 degrees. That means even though you are using a 6-year-old or 7-year-old 3D printer, you will be able to print up PLA, TPU, ABS, and all of this will go smoother throughout our hot end. And basically, all of the heads, calibration systems are existing in the current today's market. So we kind of completed the printer, but all missing is the rail systems. And with that way, you will be control up all of your 3D printers with a multicolor and multi-material way in a single print. So this is the current segment we have. 70% of our customers are B2C. We are mostly selling to hobbyists and designers and all of the end users. In B2B, we work with several companies that do industrial work in different materials. They use one print, but the print is consistent of different materials. It goes to them. And of course, we are selling to printing services and distributors. Thank you. And our campaign is currently live on Kickstarter. We are doing pre-sale right now, and we are at the hall 11.1 B55H.
Awesome. Thank you so much, Orman. Just one question, how much do I have to pay on Kickstarter to be part of that?
Well, it starts from 100 and it goes up to 800. You basically customize it wherever you want.
So please go to Kickstarter, you heard it, 100 to 800. Thank you so much, Ömer. It was a pleasure to have you here. Thank you so much. So, big promise coming up. So, strong as aluminium, light as plastic, reduce costs by 80%. If you have this message on your website, some Formnext visitors are sure to listen up. Stefan Körber from Endless Industries shows us how the promise is kept. Stefan, stage is yours.
Hello, everybody. All right. Thank you so much. My name is Stefan Körber. I am the CEO and one of the co-founders of Endless Industries. And Endless Industries develops technology for continuous fiber 3D printing. And let me start off with this. We started developing our technology, and of course, the first thing we did was we talked to customers, right? So we went out to the big OEM companies that are also in Berlin, where we're from, and we talked to them, and we figured out that they're not mainly in the manufacturing business anymore. They're more in the assembly business, right? What does that mean? That means that they outsourced all of their production capabilities for strong parts and are very reliant on external contract manufacturers, right? So they get rid of all their CNC capabilities, meaning they can't produce even an aluminum part. And that means they have to go through very long internal lengthy procurement processes, and they have very long lead times for just simple L-profile metal parts. And they've already started noticing that and using 3D printing for that, right? So if you need a strong part or like a normal part quickly, you use 3D printing, but the classic 3D printing is just too weak for certain applications, right? If you need a part that is mechanically, it has to be strong, right? You need something different. And what we did is we developed a method for producing carbon fiber reinforced parts with FDM. And as I already got in the intro, we get parts that are as strong as aluminum, as light as plastic, and you can reduce your part cost by 80%. So what we did is we developed 3 products currently. We have our patented print heads that we developed ourselves, is patented, and we have carbon fiber materials that we developed ourselves and are producing ourselves in Berlin on the TU Berlin campus. And we've developed a fiber placing software that basically tells the printer where to put carbon fiber and where to put the normal plastic material. Currently we see 3 applications, mainly strong and light prototypes, right, for aerospace, for example. And then, of course, as I said, jigs and fixtures. So for everything you need to produce your own parts, there you can use this technology very well because you get a strong part very quickly and very reliably and cheaply. And of course, robot grippers are part of that because they have to be really strong and really light. And we thought, of course, about since we had the 3D printing technology, right, we wanted to do our own printer, but there's already so many great printers on the market, and we decided to partner up with established manufacturers of industrial size 3D printers, so really big machine, really reliable, everything made from steel, and really upgrade their printers and then go to market together. So we already got some protection. We got a funding that is called Access Forschungstransfer, which is given out by the BMWK from the German government. We have already 3 paying customers, and I have to correct that because I had to log in the slides early. We already have 25K of revenue, and we're not even on the market yet. And this is the team currently. Matthias developed the technology. He is a material scientist, has his PhD on TU Berlin as well, and one of the leading experts for fiber 3D printing. I myself am responsible for business development, and Moritz has a PhD in mathematics and does our software, right? So if you want to find us, we are at Hall 11, just upstairs, and at D31. It's the joint booth of Berlin-Brandenburg, and I'm looking forward to the questions now. Thank you.
Thank you very much. Applause for Stefan. It was all crystal clear, so there's no understanding question, just a question, why endless industries?
And by the name.
Yeah.
Yeah. So in English, it's called continuous carbon fibers, right? And in German, it's Endlosfaser.
Yeah.
That's why endless.
Okay.
So endless industries, yeah. And industries because there's like lots of applications, right? There's mechanical stuff, there's medical stuff, aerospace. So yeah, that was the idea.
Awesome. An excellent presentation. It leaves no more questions. Stefan, thank you so much.
Thank you so much for having us.
Our guest. Good luck for the future. For your
Thanks.
book. Thank you. Stefan Körber, ladies and gentlemen. So, increasing the printing speed of complex parts is one way to make industrial production, that's what we're all hopefully heading for, with additive manufacturing possible. Vitro 3D wants to achieve this. Dr. Camilla, I can't pronounce it, it's too heavy, but Camilla, CEO and co-founder of Vitro 3D, explains us how they do this and what role software plays in the process. But please, once.
Thank you.
How is it pronounced?
It is Dr. Camila Uzcategui.
It's too hard. Good to have you. Good luck.
Thank you so much. Well, thank you everybody for being here and for having me. My name is Dr. Camila Uzcategui, and I'm co-founder and CEO of Vitro 3D. Let's start with a question. What do these three things have in common? And it is not a trick question. All of these things are incredibly hard to make, but it's things that the world wants and needs to be manufactured and are really at the cutting edge of the future of technology. But these still have challenges around speed, materials, and accuracy in order to get the complexity, customization, and personalization that these parts all require. But what if these complex parts could be made in seconds? That's the reality that Vitro 3D is bringing into the world. Our new method works by projecting beamlets of light into a volume of photopolymerizable resin, and as those beamlets overlap in space, they're able to create a part in seconds. This is extremely fast and faster than anything in the market today. But this is not just science fiction. This is science fact. This is a prototype of our system in our lab in Boulder, and we're making this a reality. Our disruptive solution allows our system to be uber fast, use a broader range of materials, including highly viscous resins, allows us new capabilities such as overmolding, and also automating this entire post-processing in order to have parts that are made faster, more sustainably, and gives our customers a competitive edge. We've learned that we have the ability to impact a broad array of industries, and global manufacturers have told us that they're excited to partner with us in order to develop this technology for their applications. But our initial market is in the electronic components industry. This industry is huge and growing rapidly. However, they have an existential issue. They're currently using materials that have PFAS or forever chemicals and are looking to get into more complex parts that are even smaller. So the challenge of using highly viscous new resins that don't contain this forever chemicals and are able to create high-resolution parts is a challenge that is ripe for disruption by Vitro 3D. We've already partnered with a $1 billion electronic components company that is interested in co-developing this technology for their application. But this is just the start. We're looking to go into even more lucrative applications, such as the dental market and ultimately 3D printing synthetic organs. Our IP is strong, and we've been able to build such an IP because we have a set of experts in the field, and we have recurring revenue options that allow us to access customers and meet them where they're at, allowing us to be able to enter new industries and provide new applications to these customers at the price points that they're looking for. We have a team of domain experts and seasoned entrepreneurs in order to commercialize this technology and really usher in a new era of advanced manufacturing. We are currently raising a $5 million seed round and have over $1.5 million in dilutive and non-dilutive funding. And these $5 million are going to get us to first commercializable product and some pilots next year. When we started Vitro 3D, we had a mission to solve the biggest challenges in photopolymer additive manufacturing. And along the way, we found that this technology can usher in a new era of advanced manufacturing and completely disrupt the global additive technologies. Please join us on this mission. Thank you so much.
Awesome presentation, really. Thank you so much. So you mentioned the fundings that you need for the next step. So what it is needed for, what are you doing with the money? What is the current development stage of your product?
Yeah, absolutely. So we're currently in prototypes, as I showed in the video. We are looking for some funding to hire and get into our first pilots next year to actually install our system in the manufacturing plants of our customers.
And so the typical customer, you showed this example with what was it, a chipset or what? Yeah, basically.
It's an electronic connector, yes.
So it could be Infineon, companies like that. Is that the
exactly?
typical customer?
Yeah. And we envision our system to be directly implantable into the manufacturing line, so it doesn't have to be a standalone system, and it can be part of the reel-to-reel processes that these manufacturing companies are already using, and it can just go into the next manufacturing step after it's done with our process.
Awesome. Thank you so much.
Thank
so
you.
good luck with finding the fundings.
Thanks so much.
Promising solution. Thank you so much, Camilla.
Thank you.
Big applause. Oh, yeah. So the next startup, as you can see, they didn't come alone. So they brought something with me and I'm going away. So imagine we could make the production of printable polymer powder significantly cheaper and even use recycled quantity without any loss of quality. That's something I could never explain to you, for sure not. But Dominic Siribal, founder CEO of Alpha Powders, that's the one who brought the machine with him, certainly can. So, Dominic, I'm super excited to hear your presentation. Dominic, stage is yours.
What is it? You say powder, polymer powder. I say this is gold, and we are alchemists of 21st century. Today, we are here on Formnext to show you a solution for a problem that is so important for 3D printing in industrial applications, for the problem that is hindering development of this market for years. Today, we'll show you how powders will be produced to fuel Industry 4.0 revolution. Polymer powders to be used in additive manufacturing must be sufficiently small, smooth, and spherical. Only then proper quality of parts can be achieved. Right now, it's very complex, it's very difficult. It's very hard to get there. A lot of companies are trying to do that in order to drop the cost down, in order to accelerate adaptation of 3D printing in industrial applications. It would be nice to have an approach which uses low-cost input and produces superior quality powders for industrial applications. 1 year ago, on this stage, we promised you a tool. We promised you a device for lab-scale application. Today, we deliver on this promise, presenting for the first time smallest, world's first polymer powder sphericizer. Please welcome Sphere Nano. This device is the first in the category. This device is the first instance of patented spheroidization technology that we are going to scale over next and following year in order to propose world's first pilot plant production facility capable of producing spherical polymer powders for industrial applications. As far as this product is considered, this tool is designed to facilitate the research and development of novel materials. It has a beautiful interface tailored to facilitate this very difficult process. You can control every aspect of processing that takes place inside of this device. Our magic is based on very fast melting
and controlled crystallization. We tested our powders on very different ways, and what is remarkable, the quality of such powders is better than what is capable right now with using different techniques. Thank you very much for your attention, and please feel be invited to our booth at Hall 11.1. Thank you.
By the way, that was excellent timing, not only for the presentation, but the next point to come in our agenda is a panel of VCs. So as you are looking for VCs, that might something very interesting for you to come. So have you sold already a few of those machines?
No, we are at the stage of subscription and pre-sale, and we are launching Q1 2024.
Yeah. And can the people like test it at your booth? Or?
Yeah.
Yeah,
that's the idea of bringing it here.
Yeah.
It wasn't simple to bring this beast here. So as it is right now in here, we are doing testing. So we can come here, we can put some powder, we can put some presets, we can run in open system, which is the system that we are using in-house, working on novel materials. But we can also showcase you the implemented versions of materials that are already implemented in the system. And yes, feel free to invite us and see how spherical powders are made.
And just to be crazy, can somebody else bring his powder and you...
Yeah, that's the point.
Okay, sounds good. So the invitation for you, if you have something in place you want to test on this machine, you are hardly invited, I think, here to test it. So good luck with your solution.
Thank you very much.
Yeah, it was a pleasure to have you here. I don't know who's going to take this away from the stage, but you will do it for sure. So ladies and gentlemen, big applause here. So this was basically the Pitchnext event 2023 here at the Formnext on our industry stage. Yeah, they're going to take this away. So we have several other exciting points on our agenda for you to come. And after a short break, we will meet here again with 4 absolute experts in the field of venture capital or capital in the field of additive manufacturing. So stay tuned. Looking forward to see you in a couple of minutes here back on stage with our interesting panel discussion on funding, startup culture, and anything around that. See you then.